Hey everyone, welcome back to the channel. Today we'll be discussing on a very interesting topic in your car. It is called variable valve timing, VVT. We'll examine what it is, its functions, the problem it solves, how it works, and its benefits. Your engine has multiple personalities, and that's a good thing. Think of an old engine as a robot. It does one job well, but it's boring. A modern engine with variable valve timing, VVT, that's a shapeshifter. When you're cruising, it's sipping gas like a monk, but when you drop the pedal, it instantly transforms into a fire-breathing beast. How does it pull off this epic Jekyll and Hyde routine without breaking a sweat? It's all about VVT, and trust me, this one piece of tech is why your car is faster and cheaper to fill up. Let's dive in. A quick reminder to subscribe, like, and share this video. What is variable valve timing? Variable valve timing, or VVT, is one of the most clever pieces of technology in a modern engine, and it's what allows today's cars to deliver both impressive horsepower and great fuel economy. It solves an age-old mechanical puzzle. The problem it solves. To understand VVT, you must first understand the four-stroke engine cycle. 1. Intake, or suck. 2. Compression, or squeeze. 3. Combustion, or bang. And 4. Exhaust, or blow. The timing of the intake and exhaust phases, when the valves open and close, is traditionally controlled by the camshaft. The camshaft has fixed lobes that push the valves open at specific, unchangeable moments. The problem? An engine has wildly different needs at different speeds. At low RPMs, idling or cruising, the engine needs to be stingy with fuel and air for maximum efficiency. At high RPMs, accelerating, the engine needs to breathe deeply and quickly to pull in as much air as possible for maximum power. If a manufacturer tunes the fixed timing for great low-end efficiency, they sacrifice top-end power. If they tune for high power, the engine guzzles gas in the city. It's a classic compromise. The VVT solution. VVT is the mechanical solution that eliminates that compromise. It allows the car's engine control unit, ECU, to dynamically adjust the valve timing while the engine is running. Think of it as having a programmable camshaft that changes its song based on driving conditions. How VVT works. The core components that enable VVT are the phaser or cam gear, oil pressure, solenoid, and ECU. The phaser or cam gear. This is a specialized gear bolted onto the end of the camshaft. Unlike a standard cam gear, the phaser is constructed in two parts. An outer ring driven by the timing chain or belt, and an inner rotor connected to the camshaft. Oil pressure. The engine uses its existing pressurized engine oil to actuate the phaser. The solenoid, an electrically controlled valve that the ECU uses to direct the oil flow. When the ECU wants to change the timing, it sends an electrical signal to the solenoid, which opens a passage allowing oil pressure to push vanes inside the phaser. When the oil pressure is applied, it rotates the inner rotor relative to the outer ring. This rotation either advances or pushes forward, or retards or pulls backward the opening and closing events of the valves. A quick reminder to subscribe, like, and share this video. Benefits of variable valve timing: power and efficiency. VVT achieves two seemingly contradictory goals. 1. Maximizing performance, high RPMs. When you demand maximum power, for example, merging onto a freeway, the VVT system will typically advance the timing and increase the overlap, the brief moment both the intake and exhaust valves are open. Maximizing efficiency and emissions, low RPMs. When you are cruising, the engine doesn't need high power, so the ECU focuses on saving fuel and cutting emissions. The VVT system will typically retard the timing. Continuous versus discrete system. Discrete, for example, early VTEC. These systems essentially switch between two preset cam profiles, low RPM and high RPM, at a specific point in the rev range. You can often feel the VTEC kick. Continuous, most modern systems, these systems, often using independent control on both the intake and exhaust cams, like TI VCT, can infinitely adjust the timing across the entire RPM range, resulting in a much smoother, more optimized power delivery at all speeds. If you learned something new about this engineering magic, smash that like button. Hit subscribe so you don't miss our next quick tech breakdown. And hey, share this video with a friend who loves cars. Thanks for watching.